When astronomers first announced the discovery of an interstellar visitor, dubbed 3I Atlas, no one could have guessed that it might be more than just an icy comet, but a possible communication attempt launched from the depths of space. The object, which entered our solar system on a hyperbolic trajectory, caused a wave of surprise with its unusual parameters, its speed, chemical composition, and activity. Now, as it is expected to fly within approximately 53 million kilometers of Jupiter in the spring of 2026, scientists are proposing using the Juno probe's antenna to detect a possible signal in the 50 Hz 40 MHz range. The question is no longer, what is this comet, but to whom is this message being sent and why? Official data indicates that 3I Atlas was discovered on July 1, 2025 by the Atlas system in Chile. Its trajectory is hyperbolic, and its velocity during its passage through the system is significantly higher than most known comets. Its spectra also show a very high CO2 to H2O ratio, a sign that the object differs from typical comets in our solar system. These facts support the hypothesis that we are dealing with something different, not just a natural object, but an active carrier of information or technology. The idea of detecting a signal from 3I Atlas sounds bold, but it's no longer groundless. The Meerkat Radio Observatory in South Africa has detected the absorption line of the hydroxyl radical, OH, an indirect signal that the object is ejecting water, possibly in large quantities. This ejection of water, like a giant lantern in the dark, could be either natural or artificially controlled. If we accept that someone or something at 3I Atlas is initiating the ejections precisely when they can be detected, this is one of the key arguments the ejection of matter is far from the sun, and the activity is faster than can be explained by solar heating. The Juno probe's antenna is an active participant in this story. Although its primary mission is to explore Jupiter, experts propose retuning it to the low-frequency range of 50 Hz 40 MHz during 3 Atlas's flyby of Jupiter. Why this antenna? Because Juno is already in orbit around Jupiter and can receive a signal with less interference from Earth. And the object's close flyby creates conditions for signal amplification. If 3I Atlas has a transmission or relay system, the beam around Jupiter could serve as an ideal amplifier antenna. Scientists from the SETI Search for Extraterrestrial Signals project have noted a statement by Professor Avi Loeb, who estimates the likelihood of 3I Atlas's artificial origin to be significantly higher than that of previous interstellar objects. His arguments include a trajectory nearly along the ecliptic plane, a retrograde inclination, emission activity in ranges not typical of comets, and a chemical composition dominated by CO2. These deviations are not proof, but rather hints that something is wrong. If 3I Atlas is indeed sending a signal, what could it be? Imagine a module inside the object that activates when it approaches the sun or a planet, emitting a pulsating stream of particles or a radio frequency pulse. The frequency of 50 Hz to 40 MHz was chosen deliberately. It covers a very low frequency range with less noise and has long been considered a possible interstellar communication channel. If Juno's antenna is switched to this range precisely when the object passes, it might detect a repeating signal disguised as natural comet emissions. An additional argument is the flyby timing. In the spring of 2026, 3I Atlas will pass at a distance of approximately 0.36 AU, 53 million kilometers, from Jupiter. The giant planet, with its powerful magnetic field, could serve as a relay or signal amplifier. If the comet's module is designed to pass close to massive planets to amplify the signal, then our chance of picking up the signal in the spring of 2026 is unique. But if this hypothesis is correct, what does this mean for us? First, we must recognize that visiting comets may not be mere debris, but mechanisms. Second, we must acknowledge that the observation window is short. If we don't detect a signal now, the object will disappear from our view, as scientists are already saying. Third, the act of observation itself becomes part of the experiment. How we react, what we do, how we prepare. Everything can be part of the answer or the test. If 3I Atlas is considered artificial, then many questions arise: who launched it? When? For what purpose? Perhaps it was created by an ancient civilization long gone, or by a technological system operating autonomously for billions of years. Perhaps its purpose is simply to observe or switch on life systems like us. In the spring of 2026, when the comet module passes Jupiter, we will witness not just a flyby, but the possible activation of a second act, a signal amplified by the giant planet's magnetic field. As night falls and we look up at the sky, 3I Atlas has already become a symbol of both fear and hope. Fear because the unknown is frightening. Hope because the first entangled interstellar body could become the first bridge. Whoever picks up the signal could gain not just data about another world, but a glimpse into the structure of the universe itself. And if, in the spring of 2026, Juno's antenna detects a repeating pulse at 50 Hz to 40 MHz, it will be more than just a discovery. It will be the beginning of a conversation we haven't yet dared to have. When the first measurements revealed that 3I Atlas was emitting a weak but stable emission in the tens of hertz range, many scientists assumed it was an artifact of the instruments. But after 2 weeks of observations, this coincidence became impossible. The signal repeated every 11 hours and 36 minutes, exactly the same amount of time as one rotation of the nucleus around its axis. However, this rotation didn't coincide with the change in brightness, as expected. The comet wasn't simply reflecting light. It seemed to be modulating the space around itself. Astrophysicist Carl Manz of the University of Arizona was the first to suggest that this could be a low-frequency radio signal emanating from the object's interior. His team calculated that using the antenna of the Juno probe, which will be approximately 53 million kilometers from the comet in the spring of 2026, it would be possible to obtain a relatively clean spectrum free of terrestrial interference. The frequency range, from 50 Hz to 40 MHz, coincides with the range of natural plasma oscillations in Jupiter's magnetosphere. This means that the signal could be detected as a resonant response, if indeed it exists. Interestingly, it's precisely this frequency range that many theorists consider the most likely for interstellar communication. At these frequencies, radio waves pass through plasma with virtually no loss and are not distorted by interstellar dust. If a source truly wanted to send a message toward a habitable planet, they would choose precisely these frequencies. Too many coincidences. When Manz's group presented their data at the American Astronomical Society conference, they were met with suspicion. Their reports noted anomalous signal polarization and a strange dependence on Jupiter's position. NASA scientists explained that the comet was likely simply interacting with the solar wind. But Professor Michio Kaku stated in an interview, if 3I Atlas is capable of producing sustained low-frequency radiation, it's no longer just an observation object, it's a source. Avi Loeb also weighed in on the analysis. He wrote on his blog, "Since Oumuamua, we've seen the universe challenge us again and again. If 3I Atlas shows controlled dynamics in electromagnetic activity, we must consider an artificial origin, however inconvenient." His words sparked debate, as they always do. Observations continued, and new data soon emerged. The comet, moving away from the Sun, should have lost activity, but instead it increased. Chemical spectra showed increased emissions of water and cyanide. However, the surface temperature did not increase. This is physically impossible. The only explanation is an internal heat source. Scientists have calculated that the emissions are 3 to 4 times more powerful than solar energy. This is equivalent to the operation of a small nuclear reactor. But what natural process is capable of generating energy so uniformly and consistently? Manz and his colleagues suggested that there might be a cavity within the core where reactions, possibly electrochemical, that release water vapor occur. This would explain not only the activity, but also the low-frequency signal. The reactions could be accompanied by plasma oscillations, generating magnetic pulses. But if the mechanism is stable and repeatable, it is artificial by definition. Skeptics remarked, "You can't attribute intelligence where physics suffices." But the facts are stubborn. 3I Atlas is the third interstellar body ever observed, and the strangest of them all. It combines features of a comet, an asteroid, and something that defies classification. It has a perfect axis of rotation, a non-random trajectory, and a source of internal energy. Amidst controversy, NASA officially approved a proposal to use Juno equipment to monitor radio frequencies during the comet's passage past Jupiter. The experiment has been unofficially dubbed Juno Echo. It is planned to collect data continuously for 3 days, when the distance between the objects is minimal. During this time, the antenna will monitor the range from 50 Hz to 40 MHz, where bursts have already been detected. If a repeating pulse sequence is detected at this point, it will be the first direct evidence of interstellar radio communication. But the risk is also great if the signal turns out to be unnatural and deliberate. The question of what to do next will become practical rather than theoretical. The spring of 2026 will be a moment that will have the entire scientific community's attention. According to NASA and the European Space Agency, this is when 3I Atlas will pass at its closest distance from Jupiter, approximately 53 million kilometers. To put this into perspective, this is less than the distance from Earth to Venus at perihelion. And during this short window, humanity will have its first chance to test whether an interstellar object is capable of emitting a radio signal. Scientific laboratories are already preparing the equipment. The Juno probe, orbiting Jupiter, will be switched to low-frequency monitoring mode by March. Its antennas will be reconfigured to receive the 50 Hz to 40 MHz range, frequencies typically used to observe plasma flares, but which SETI theorists have long considered as a possible channel for interstellar communication. For 3 weeks before its approach, Juno will begin listening to the cosmos, intently and continuously, searching for any repeating pattern that could be distinguished from background noise. Scientists are already making predictions. If 3I Atlas is indeed a natural comet, there shouldn't be any signals. At most, weak plasma fluctuations caused by the tail interacting with the solar wind would be enough. But if the object is artificial, it could have a built-in transmitter, not in the traditional sense, but as part of its core structure. Then, as it approaches Jupiter, the planet's magnetic field could act as an amplifier, activating a radio emission. Physicist Karl Mantz, one of the initiators of the Juno Echo experiment, describes the expected pattern this way. If a signal exists, it will manifest itself as a short series of low-frequency pulses with a fixed modulation, roughly in the range of 1 to 10 Hz. Anything above this threshold and repeated at regular intervals can no longer be considered random. Mantz's team has developed algorithms to filter out Jupiter's background noise, the very radio emissions that make the planet one of the loudest objects in the solar system. If 3I Atlas speaks, Juno should hear it first. Preliminary calculations suggest the object will maintain active emissions during its closest approach. This is unusual. Comets lose energy as they move away from the Sun, but Atlas, on the contrary, increases its emission. Telescopes are already detecting increased evaporation of water and cyanide at distances where ice should not melt. This means the nucleus may have an internal heat source. Its origin remains a mystery. Some believe it is due to the decay of heavy isotopes, while others believe it is due to an artificial mechanism controlling the emissions. If the artificial origin theory is correct, then approaching Jupiter could act as a trigger. The planet's magnetic field can induce currents in metallic structures, and if 3I Atlas contains even a small amount of conductive material, Jupiter's field could wake up the dormant mechanism. In this case, Juno would be able to detect not just noise, but a sequence of pulses, perhaps even a code. Harvard's Avi Loeb calls the upcoming observation a test for humanity. He writes, "If no signal is detected, it will merely confirm that we have encountered a highly unusual comet. But if a signal is detected, we will witness the first interstellar message, not necessarily addressed to us, perhaps simply left for anyone who can listen." NASA and ESA have already synchronized their observation schedules. In parallel with Juno, ground stations, including Green Bank, Meerkat, and the Very Large Astronomy Observatory, will monitor the same wavelength. Scientists want to achieve cross-validation. If all receivers detect the same signal with the same delay, this will be a strong indication of its authenticity. For these weeks, humanity will literally stand still. There will be no flashes or light visible in space, only data. These are mere numbers, but they could change our understanding of the world. If Juno's antenna detects repeating pulses, even faint ones, we will have the first proof that 3I Atlas is more than just a space rock. It could be a device launched millions of years ago. a beacon that activates when it encounters a magnetic field of a certain strength. But not everyone shares the enthusiasm. Skeptics warn that low frequencies are too sensitive to interference. The Sun, Jupiter, and even Juno's own systems can generate false signals. To draw definitive conclusions, measurements will need to be repeated with other instruments. Therefore, a synchronous observation with the LOFAR radio telescope in Europe and the Japanese ALMA is planned for the spring of 2026 to eliminate the possibility of error. Meanwhile, the question is growing louder in scientific circles: if a signal is indeed detected, what next? Determining its source is difficult. 3I Atlas will pass by and disappear back into interstellar space, beyond its reach. It's impossible to answer. We'll only be able to listen. But the very presence of the signal will be an answer, proof that we're not alone. Some researchers are putting forward an even bolder hypothesis. The signal may be diagnostic rather than informational. In other words, the comet is not a message, but a scanner. As it passes planets, its magnetic field reacts to their radiation, recording their characteristics. Perhaps in this way, an older civilization is tracking the evolution of other worlds. If so, then in the spring of 2026, we will become part of this process, a fleeting measurement in the Great Web. This idea sounds terrifying, but also majestic. After all, if 3I Atlas actually collects data and transmits it, then someone, somewhere, will learn that a civilization capable of hearing the whispers of space has emerged on a small blue planet in the solar system. As the object approaches Jupiter, telescopes will record every splash, every change in brightness. Scientists expect that by April, the comet will again exhibit anomalous water emissions, as if breathing. And if at that moment Juno's antenna registers a rhythm unlike any natural one, humanity will understand the cosmos has spoken. And then all that's left is to listen. Without jumping to conclusions, without making hasty statements. Just listen. Because perhaps this isn't just a signal. It's an invitation. And once we stop being afraid, the conversation we've been preparing for thousands of years will begin. However, as the experiment date approaches, more contradictions emerge. In some labs, excitement reigns, anticipation of the discovery, while in others, a hidden tension is palpable. Some astrophysicists admit they're unsure whether they really want to hear this signal. After all, if it turns out to be artificial, someone must have created it. And then the inevitable question arises: where are they now? Professor René Stein of the European Observatory stated, "We risk witnessing a moment for which we are neither technically nor psychologically prepared. We are capable of detecting a signal, but unable to comprehend its meaning." His words have provoked a wave of criticism, but there is a grain of truth to them. After all, every discovery brings not only knowledge, but also responsibility. If in the spring of 2026 we hear not just noise, but a pattern, humanity will have to acknowledge that it is no longer an observer, but a participant in a dialogue. A general rehearsal is planned several weeks before the encounter. It will involve ground stations from Greenland to South Africa, synchronized via a network of atomic clocks. They will all listen to a single point in the sky, the location where 3I Atlas will appear. These hours will be the most intense in the history of radio astronomy. Even if nothing happens, the mere fact that a planet will unite to listen to the universe for the first time will be a significant event. Leaks are emerging amid preparations. In closed forums, scientists are sharing observation spectrometers detected faint repeating pulsations in the 3I Atlas region as early as late 2025. They are small but stable. Some participants call them the object's breathing. Others call them a pulse. NASA refuses to comment, claiming they are the result of solar wind interference. But independent astronomers are certain there are too many coincidences. The frequency of repetitions, the duration, the pauses, everything seems to follow a pattern. Meanwhile, heated discussions begin on forums. People argue, some joke, others are downright afraid. Theories begin to emerge that the signal may contain not just information, but energy capable of influencing the radiation belts. Of course, this is a conspiracy theory, but anxiety is growing. People sense that something important is happening, even if they don't understand what exactly. Philosophers and psychologists are discussing how humanity's perception of the universe will change if contact occurs. After all, it won't be a face-to-face encounter, but a clash of worldviews. We're used to thinking of the universe as silent. But what if it was simply waiting for someone to finally create ears capable of hearing it? Juno will be ready to receive signals by March. A few days before the flyby, the team will turn off all telemetry carrier signals to clear the channel. The spacecraft will enter autonomous listener mode. If a signal appears, it will be recorded directly, without human intervention. Decoding will begin back on Earth. The scientific world will hold its breath. No live broadcasts, only anticipation. After all, once the object passes Jupiter, there will be no second attempt. After that, 3I Atlas will be gone forever, beyond the orbit of Saturn into the cold darkness, where none of our instruments will ever reach it again. And that's precisely why this upcoming observation will be perhaps the most important event of the 21st century. It will determine not what we know about space, but how we feel about it. We've always feared the void, but perhaps the void was the answer, simply spoken in a different language. When the Juno probe points its antennas at the black space and turns on listening mode, a straight line will appear on the screens of the control centers, and billions of eyes will stare at it, just as ancient people once looked at a fire, waiting for a sign. Perhaps it will remain steady, and then it will be silence. Or perhaps it will flicker, just once. And this trembling impulse, even if only lasting a split second, will divide history into before and after.